Hello everyone. Continuing on section 2.2, which is basic differential rules, we will be looking at derivatives of sine and cosines. So let's start with the derivatives here in the trig functions. So the differential of a sine function is a cosine function, and a differential of a cosine function is a negative sine function. So let's look at an example. So you want to find the differential of the function negative 3 sine x plus cosine x. If you want to find the differential, remember it's going to be negative 3 sine x because it's a sum of two functions plus cosine x differential. Okay, so when I write cosine x prime, basically I'm saying differential of cosine function. Now the first expression, negative 3 sine x, it's a constant multiplied to a function. So according to the rules, the constant comes out and you're going to take the differential of the sine function, and this is the nice little differential of cosine, which is negative sine. Okay, now the first expression in this function, differential of sine, we know is cosine, so your final answer is negative 3 cosine x minus sine x. Let's go ahead and do some more examples. Now let's look at the differential of this first function, x to the power negative 2 plus 7 sine x minus 5 cosine x. So hopefully you have become more comfortable and you remember the rules. Once again, I'll write down the power rule, guys, here. Remember, y equals x to the power n. So the differential of y is n times x n minus 1. That's the basic rule we will be literally using. And the differential of sine is cosine and cosine is negative sine. So let's come back to the first example here, differential of f of x, which is f prime of x. Now this is a nice little expression in the proper form. So the differential is what? Minus 2x minus 3, because minus 2 minus 1. 7 is a constant, you just basically pull that out and you take the differential of the sine, which is simply cosine function. Now minus 5 is a constant, so minus 5 out, the differential of cosine is a negative sine. So your final answer is negative 2 x to the power negative 3 plus 7 cosine x plus 5 sine x. Notice I am not writing down the way I was doing it earlier every time to take the x to the power minus 2 differential and other steps. I'm just going straight to this expression, and I know by this time you guys are more comfortable and remembering the rules. Okay, let's look to the next example. F of x is negative 1/3 cosine x minus 2 x to the power minus 2. So we want to take the differential of this function. Now minus 1/3 basically is your constant, you keep that out. You take the differential of cosine x. Which is basically negative sine x. Now remember the next expression, negative 2x to the power minus 2. So negative 2 is a constant. And the differential of x to the power minus 2 is what? Negative 2 times x to the power negative 3. Let's clean it up and write it nicely. So it's 1/3 sine x plus 4 times x to the power minus 3. Okay, let's look at the next expression. F of x is x squared minus 3x plus 5 over x squared. Now this is not the normal expression we have seen in terms of power rule because we have something in the denominator. But if you remember that if you have only one term in the denominator, you can actually write it in, you can basically take the numerator expressions and write individually every term in beneath the one term in the denominator. That way we can get in the expression of the forms you're looking at. So it's going to be x squared divided by x squared minus 3x over x squared. So it's basically algebra, guys. First we will have to do 5 over x squared. Now clearly I hope you guys remember the exponent rules. If you do not, just go and have a quick review of them. So the first expression is basically 1 minus 3x over x squared. So you can take this square on the top. So what you have is 3x times x minus 2. Let me write that nicely. Plus 5. You take x squared on the numerator, x to the power negative 2. So finally, your expression f of x is now written as, it's much more better to clean it up and then do the final work. So minus 3, in other words, take the final differentials, x to the power minus 1 plus 5 times x to the power minus 2. Now, notice we can do nice little differentials. Very simple, and it's in the form we are more comfortable with. So what is the f prime of x? Differential of 1, it's a constant is 0. So don't have to write anything. Negative 3. Differential of x inverse is going to be what? Minus 1 times x to the power minus 1 minus 1. That's minus 2. Plus 5 times differential of x to the power minus 2 is what? Minus 2 x to the power minus 2 minus 1 minus 3. Now, write it nicely. Simplify, in other words. This is the minimum simplification I would need, guys, when you're doing the math. That looks much more professional here, I would say. So minus 3 times minus 1 is 3. 3 to the power x minus 2 minus 10 times x to the power minus 3. That's the way I would like the answers to be. I'm not going much more forward like positive exponents. No, that's enough. Okay, so we have learned the differentials of sine and cosine. We did some examples. So what do we do, guys? Next is practice. So here are some 4 problems for you to practice, and kind of a lot of things involved. So you will get a lot of practice here. Okay, now we are going to look at some very special cases of applying the things we have learned. So let's start with the very first example. It says find the slope of the graph of this function fx equals x to the power 6 for each value of x where x is minus 1, x is 0, or x is 1. Now things you have to remember. Remember what we said, that the slope of the tangent line to the graph of a function at a point is given by f prime of x evaluated at that x, okay? Where basically is the limit is delta x approaches 0 of f of, so this would be at a point, so this I would say is c. At a point, let me write this one, say p, c and f of c. So this would be f prime of c, which is limit delta x approaches 0 of f of c plus delta x minus f of c over delta x. So the derivative, so the first thing is if I want to find the slopes. Now this is where you're applying it's an application of the definition to different kind of functions. So remember, the main relationship we know is that a slope of a tangent line to a graph of a function is nothing but the differential of the function at that point. Okay, and so the first thing is we find the derivative. Anytime you're given a problem, just do the normal differential. So we do the normal differential of the function. F prime of x is 6x to the power 5. Now we want to find the slope of that for different x values. That means when x is minus 1, the slope is what? F prime of minus 1, which is basically minus 6. When the x is 0, the slope is f prime of 0. 6 times 0 is 0. And when x is 1, the slope is 6. Okay, now let's look at things we have learned earlier too. And I'm just basically now combining things we've learned previously to the things we have learned now. Here's it. It says find an equation of the tangent line to the graph of the function fx equals x squared minus x at a point 3 and 6. So let's read the question. Again, find an equation of the tangent line to the graph of this function at a point 3 and 6. Now if you recall, the first thing it says equation of a line. And what is that line? It is a tangent line. So two things are happening together. Something we learned in algebra, that is equation of a line. And now from calculus, we said that line is a tangent line. So that means if it is a tangent line, remember tangent line means what? That M is nothing but f prime of x, where x is evaluated at C, wherever that point is. So this 3 is my C. Okay, so let's look at this one. So for the first thing is, how do you write this one? Equation of the tangent line at a point, say x1, y1, is y minus y1 equals m times x minus x1. Now, because this tangent line happens to be a tangent line, so this m is f prime of x evaluated when x is C, or the point C and f of C here. So where m is f prime of x, I've written it down. So the first thing we do is we find the derivative of this function and evaluate that derivative at the given point. So f prime of 6 is 2x minus 1, and when you evaluate this function at 3, what do you get? So f prime of 3 is what? So it's 3 times 2, so just remember, it's 2 times 3 minus 1. So it's 6 minus 1 is a 5. Now we have got x1, y1 already by the problem, and now we have found the m. What we do? We just plug in the values. So y minus y1 equals f prime of x times x minus x1. Plugging in the value, we get y minus 6 times 5 times x minus 3. So when you solve this little algebra, you get 5x minus 9. Okay, let's look at another problem, with a very special case there. It says determine the points at which the graph of the function y equals x cubed minus x has a horizontal tangent line. Now, not only we're looking at tangent lines, but we're saying that tangent line is a very, very specific one. It's a horizontal tangent line. Okay, so we're looking at the points at which the graph has a horizontal tangent line. So what is my function? It's x cubed minus x. So once again, what's the interpretation of the horizontal tangent line? So if we say that if a graph of the function has a horizontal tangent line, that means the slope is 0. Notice how what is horizontal? A horizontal line always has slope 0, right? Now, if that horizontal line is a tangent line, that means the slope is given by f prime of x. So slope of the horizontal tangent line to the graph of the function at a point equals f prime of x equals, say, y prime equals 0. So basically I'm saying y equals f of x. So I'm just writing down different ways you write your function here. So this is the function. So whenever you get a problem says find the points where the graph is having a horizontal tangent line, what I'm literally saying is, so you look at the graph, where are the points? In other words, we look at this graph and we'll figure it out. Okay, so let me actually show you with the graph, and then I will do the math here also for you. About the graph, so notice this is where on the web page I go, and it is a free graphing calculator, desmos.com calculator. You can also do it there. When you open this one, on the left hand side you write down the expression x cubed minus x, and when you do that, automatically a graph is drawn, and that's where the graph you see here. And in this graph, notice there you see the graph at the point negative 0.577, you see a horizontal tangent line, and also at the point 0.577, you see a horizontal tangent line. Okay, you can see this little arrow of mine moving. So that's where there are two horizontal lines. So graphically, we already see it is at this point, negative and positive 0.577. We're also going to show it through the mathematics using calculus that these are the points we will get. Okay, so let's go back to our problem. So we said that y prime is 0. So when we do the math here, we will go down and see when you do this math here. What do you see here? So y prime is 0. Y prime, remember, your f prime of x. Remember, your fx is what? It's x cubed minus x. So f prime of x is what? 3x squared minus 1. You're looking at the points with the horizontal, you have a horizontal tangent line. So x squared equal 3x squared minus 1 is 0. X squared is 1/3. X is plus minus 1 over square root 3, which basically, if you will notice, it's plus minus 0.577. So the graph of the function y equals x cubed minus x has a horizontal tangent line at 2 points. Graphically also, we have seen that, here. So this point and this point. Okay, now one more special case, guys. This is related to the things we talked about, differentiability and continuity. So this question says, find a and b such that the function f is differentiable everywhere. So my function fx is given to be, it's a piecewise function, ax cubed, where x is less than or equal to 2, and x squared plus b, x is strictly greater than 2. Now, as this function is continuous everywhere, this function has to be continuous at x equal to 2 and also be differentiable at that point. Recall from our continuous lecture on continuity of the functions. We said when we say function is continuous, we say the left hand limit equals the right hand limit equals the value of the function at that point. Now our a happens to be 2, guys, over here. So the first thing we're going to do is, what is the value of this function? So let's come here. I'm going to write down the function here, fx equals ax cubed and x squared plus b, let me just, which is x greater than or equal to 2 and x is strictly less than 2. Let me just check that again. Oh, it's less than or equal to 2, sorry. And this is strictly greater than 2. Okay. Now, so when we say find the value of the function at 2, so value of the function at 2 is what? It's where is the equal sign you see? So it's ax cubed. So at this point, what I know is it's 8, you do not know. So it's x cubed is what? 8. That's it. The left-hand limit says limit as x approaches 2 minus of the function fx. So you look at all the value. What is the value of the function when x is less than 2? It's ax cubed. It's 8a. And then the right-hand limit says that the limit as fx as x approaches 2 positive, that's the right-hand limit, is going to be limit, the expression is x squared plus b, and you replace the x by 2, it's 4 plus b. So because its function is continuous at 2, the left-hand limit equals the right-hand limit, that means 8a equals 4 plus b. Now remember, we have to find the values a and b. At this point, we can't do anything because we do not know a and b. 2 unknowns and 1 equation. So we have to go back and see, okay, what else is given to us? It says function is differentiable everywhere. Now remember, if a function is differentiable, it is continuous. So we tried the continuous case. We are having the scenario that 8a equals 4 plus b. So we have to go and look at the second aspect is function is differentiable. So when function is differentiable, let's come back here. If a function is differentiable, it simply means that the left-hand derivative must equal the right-hand derivative. Remember, what is f prime of x? You have to keep this in mind. Your differential is the limit as delta x approaches 0, f of x plus delta x minus f of x over delta x. Remember, your differentiable function is, if you say a derivative of a function that's f prime of x, you're saying that this is the definition that the limit exists. What is the meaning of limit existing? That the left-hand side equals the right-hand side. Because it's a derivative, so the left derivative must equal the right derivative. So what we do is the function which was given to us, let me write that down, it was what? Ax cubed and x squared plus b, and the function is x strictly greater than 2 and x less than equal to 2. Now that's the original function. When you take the derivative, guys, the equal to may or may not hold. So that's why when you're taking the differentials, we look at strictly less than and strictly greater than. So f prime of x is 3ax squared and f prime of x is 2x for x strictly greater than 2. Now for it to be differentiable at 2, the left-hand derivative must equal the right-hand derivative. Okay, again, there's a typo here. So it's 2, it should be a 2, guys. So it's 3a 2 squared, because remember looking at differential at 2, 2 times 2, 12a is 4, a is 1/3. So if we know the value of a, what is b? 8a minus 4, which is 8/3 minus 4, which is negative 4/3. So once again, I would like guys you to practice. And they're very important. These are scenarios which involve the practice of special cases of function, basically like finding the slope of a specific point, equation of a tangent line, horizontal tangent lines, and functions being differentiable. So these practice problems are kind of similar to the ones I have done here in this lecture. Thank you.